I'm going to show you a sneak peek how it's going to be looking at the end. Basically, we have a file viewer or like image viewer. We can basically scroll through all of the files in the directory. We can zoom in on files. We can full screen files like this and look at the stuff in full screen. We can scroll through, and we can even rotate if we want. And there's this gallery view where we can select like this. And you might ask yourself, okay, so are we going to use GTK or some other library? Actually, it's all going to be done in C and OpenGL. But we're going to be using an OpenGL abstraction library. You probably know Raylib. It's a library similar to that. All right, let's make a image viewer. Let's call it something like fv.c, because file viewer. Okay, so let's have a quick hello world. I think a hello world is something that every good programmer needs to get started, right? Do you think every good programmer needs a make file? It's debatable, I guess. Let's have a like that, and let's make. And probably, yeah, every good programmer definitely needs a build directory. All right, let's just remove that. And then let's make again, and let's have a build fv, and we have a hello world. Now, the thing is, we kind of need to open our Firefox, and let's go to GLFW example. We are going to be using GLFW for the windowing. So let's just copy that, and let's put all of that here, right? Let's hash include glfw slash glfw3.h to make the functions compile, and then let's have something like lib is equal to -l glfw, and then let's link with lib make, and we also need gl as usual, and we have our window. Okay, so next thing, we're going to need our rendering context, and the rendering context is we're going to use my own library for that. It's called Runara. So let's look up Firefox, and let's go to Runara, and that's basically the library that I have developed over like the past 2 years ago was Prime, and like 2 years ago I developed the library, and I think it's very easy to use, so we're just going to use that one. Okay, and we're going to use this commit specifically because after that there were some changes in the API that are not really useful for us. So let's copy that commit, and let's git clone https github.com/cococry/runara, and we're going to cd into Runara and check out that commit. And and then we're just going to make. For making, you will need some dependencies. I think the main dependencies are like FreeType and Harfbus, and also CGLM. And then you just sudo make install, and yeah, I think we really don't need that because we're going to use it locally. So what we are basically going to be doing is we're going to include runara/runara/runara.h, right, locally. And then we're going to go into our libs and say we want to link with runara/lib, but as a L directory. And then we want to link with Runara because in lib there's lib Runara. And yeah, that's basically that. Now we can start like saying, after we make the GLFW context, we can say we have a render state, right? So rn init 640 by 480 GFW get proc address is the loader, and we have to cast it to an RNGL loader. And this is going to basically set up all of the OpenGL rendering context, and also it's going to set up the all of the Runara state, because Runara has a lot of things going on, like glyph caching or text rendering setup, and in general shaders and all of the OpenGL things you can imagine. Then we basically want to begin with our state and end with our state. And before that, we want to clear color with, let's say, it's not LF, it's RN, color from hex, 111, 111. Or actually, no, we're going to make it light mode, right? As we had it in the thumbnail. So, and then let's just rn rect render, just to see if everything is set up correctly. Let's rect render a 50 by 50 red rect. Like that. And then we want to wait events, actually, because we are not a game, we are an actual application. Wait events is basically let's make. So what I was trying to say is that GFW wait events, it's basically GFW poll events is just polling for events 60 times a second constantly and churning your CPU for no real reason. And GFW wait events just lets the program sleep when nothing is happening. And that's basically what we're trying to achieve, because we are not a game where everything is updating 60 times a second. Okay, so we need to link with the math library, and we will also need to link with harfbus and freetype, actually, because they are required for Runara. And would you look at that, we already have something drawing on the screen. That's perfect. Now we are an image viewer, right? So there is a functionality in Runara called textures. Obviously, it's an OpenGL abstraction, so yeah. But what we can do is load a texture from a file path. So we can just say something like image. Let's search up an image. Yeah. I think this is a cool image, right? It's a JPEG image, and it's just from JPEG XL, I think. And we can just use it, but why is it so why is it so dark? And it's not even a JPEG. It's an AVIF file. Okay, so I think I found this kind of cool image of a mountain. So let's have mountain.jpg be in our image viewer like that. So let's save that, and let's have a /mountain.jpg and just load the texture, right? And then let's say after rendering a rect, then we can just say rn image render, right? So we want to render an image at let's say 100 100 with the color white. We don't want to tint it, right? And let's just pass the image and see what happens. And would you look at that? It's a part of an image. Why is it just a part of an image, right? So what we actually have to do is we Runara automatically culls everything that's outside the screen, and we just told Runara that the screen is this size, 640 by 480. So what we want to do is have a resize callback that is going to be fired when our window resizes, and basically say that we want to resize the display in this case. So, and for that we already are forced to have some kind of global state. So let's introduce a global state where we store the render state. So let's have a global state s and say s.render, and we want to resize to the new width and height. All right, then we are going to say GFW set frame buffer size callback of the window to actually resize callback, right? So it's going to be the resize callback, and that's basically that. So let's see. Okay, interesting. We segfault. That's because we say state is equal to, but we actually have to say s.render is equal to. And then everywhere where we use state, we can say s.render, right? Just like that. And let's see. Now we can actually resize things. Let's put those away, and we can see the entire image. I think this is the image viewer done. Okay, guys. Okay, so I think the next thing we definitely want to do is we want to correctly like position the image, and also like image viewers have this functionality where they don't just render the image like it's actually like the size of the image. Like image viewers do this thing where they don't just render the image like this, they actually perform aspect ratio manipulation on the image, basically retaining the aspect ratio but still positioning in it. So basically what we want is we want to retain the aspect ratio of the image but position it inside the window box. So it's basically like letterboxing. Okay, so before we continue, I noticed something. We had runara/runara/runara.h, but that's not correct. We need runara/include/runara.h, because then the path will be wrong. Okay, so to actually do real letterboxing, there's the formula, which is basically we get the best ratio by checking what is the smaller like final ratio, the screen's width divided by the image's width, or the screen's height divided by the image's height. And then this is the best ratio, basically, that is going to choose the correct ratio if we resize on Y and on X correctly. And we then just want to multiply our image size by the ratio, and this is like the end image size. So let's have that. Float best ratio is equal to, and then we actually, let's borrow min and max here. So like this is equal to min s.render width, so the screen width, divided by float image.width, so this, and s.render height divided by float image.height. And this is basically our best ratio. And then we say vec2 s image size is equal to vec2 s, and then image.width times best ratio, image.height times best ratio. That's basically our image size, and we can already use that. But what we also want to do is center our image on the available space, meaning we need to use the centering formula, which is just vec2 s and then image size s.render width minus divided by 2, and that's the same thing for x, for y, so render height minus image size dot y divided by 2. Alright, so then we have center position and letterboxed size, and when we take those together, we can say image size, image pos actually, and then to actually specify a size for the texture, we have to do something like this. rn texture dot width is equal to un32t image size dot x, and then dot height is equal to un32t image size dot y, and they include the wrong thing where the API is different. That's always a problem, right? So that's basically this, and then we say dot id is equal to image.id to actually display the OpenGL texture. And yeah, this should be letterboxed already. So let's see. Nice. So now we always have the perfect ratio depending on how large the height or width of the screen is. So they basically always fit. And it's already looking more like an image viewer, right? So I think the next thing we want to do is to actually implement zooming, because it's like a pretty like not straightforward thing, and I want to kind of get this out of the way. So let's have in our global state, let's have a variable called zoom, right? So how far we have zoomed in, and then let's have a scroll callback, which is just when we zoom basically. So double delta x, double delta y, and we will just say s.zoom plus equal delta y, and then we say s.zoom is equal to min s.zoom 1, and it's actually going to be max. So that, for example, when zoom is like somehow 0 or something, we just clamp to 1. And then we can also say min that, and then like 15 or something, so we don't go in too far. And then, yeah, then we kind of want to actually store our image position that we calculated, so that we can change it from the zooming thing. But what we first should probably do is, so this is basically our image size, right? But we want a scissor that displays this size, but we want to render an image that is larger, like by factor of zoom, inside of the scissor, so that we always see the like position we have zoomed in by just enlarging the image, but the scissor just keeps it from like bleeding out. And so for that, I'm wondering, there's like a thing in Runara that is kind of more optimal than scissoring, because then we don't have to have like multiple draw calls, which is just cull. Let's just use that, right? So let's cull start x from, so I think we have to s.render, sets the x coordinate from which to start culling, yeah. Okay, so we want to cull from image pos.x to index, which will be image pos.x plus image size.x. And then we want to say start y, and this is going to be .y, and this. And then we say rn unset cull start x state or s.render. Okay, so we are basically culling to the image's coordinates, and then we can already say something like times s.zoom in here. So we basically just overshoot, or not really overshoot, but we basically just zoom, but without overshooting because of the culling. So let's say set scroll callback, window scroll callback. Okay, interesting. I think this is happening because we have zoom set to 0, meaning we just draw a 0 width and 0 height image. So let's set this to 1, okay. And now we can already zoom in, right? So we can zoom in like this, but this is not like the zoom we want. We want to zoom to the cursor. So that's where another thing comes in, which is basically first of all saying something like vector_s image pos image size, and then we have s.image size, and yeah, let's just query replace that, and yeah, that's basically that. And then we can kind of modify it from the scroll callback, because in the scroll callback, what we want is we want to basically get the cursor position and then zoom to the cursor position. So how do we get the cursor position? We want cursor pos of window, and we have cursor x, cursor y, cursor x, cursor y, like this. Okay, and to actually offset the image pos correctly, we will have to do something like is equal to cursor x minus cursor x minus s.imagepos x, and we kind of are on x here, and then this times like the factor this zoom has. So what we probably want to do is have something like old zoom is equal to s.zoom, and then we do float zoom factor is equal to the new zoom, so s.zoom is equal to s.zoom divided by old zoom. This is basically our zoom factor, and then we just say times zoom factor. Okay, but currently we are changing the position in the scroll, and then every time we are like changing it back to just being centered. So what we probably want is this size and position should be only calculated like in some kind of separate function, and this separate function is something like calc ratio letterbox, and image is basically going to be s.image. So let's have a rn texture image, and this is s.image and s.image and s.image and s.image and s.image, and then the calc ratio letterbox will be called only during resizing and when we load the texture initially. Okay, and this basically centers the image around the cursor. So let's check. Okay, so what we definitely have to do is have the cull pos not be the same as the offsetted image position. So we want those to be instead of image pos, we want cull pos. Nice. Okay, now we can zoom in. Perfect. Okay, so we basically don't want the image position to ever be offset so far that this can actually happen. So we want it to be clamped. So we want to clamp it with GLM clamp because we already have that. So let's use that. We want to clamp this between min being the view width. So let's have view width be s.render.render width minus the image width, which is s.image size.x times s.zoom, because we are talking about the actual displayed image width. And this is like the maximum offset for things like if they go to the left, to basically have it still showing on the right, so that the right is exactly fitting into render width, so that it's not like under fitting. And max, we want max to be at 0, because something more than 0 would just cause it to like underfit on the left instead of the right. So this is also not what we want. Meaning this is basically that, right? But this clamp only really makes sense if the image width, like this thing, is actually greater than the render width. Because what if the image actually totally fits into the render width? Then this clamping doesn't really make sense, and we can just center the image then. So let's see. Let's have something like if this is greater than s.render.render width, then we want to clamp. And else we want to just center, right? Because it fits into the screen, so we want to center on like the visual available space. So available space is render width minus the s dot image size times s dot zoom divided by 2. All right, and then the same thing for the y. Can we just do this and then basically say dot x or like x y and width height? Yeah, probably, right? So this should actually work, I think. Oh, perfect. That totally worked. Okay, so the image was probably because of this. We are actually setting the parentheses wrong. Let's see. Yep, it was because of that. Nice. Can we actually zoom in forever? Yeah. So why can't we actually zoom in forever? So min s.zoom and 15. Okay, I fixed this also because apparently you can't do it in one line. And now we already have a image viewer that can zoom shit. That's actually great, right? So let's actually tackle UI now. Actually, I'm wondering, yeah, something like this, for example, we would probably need something like calc ratio letterbox, and we want s.zoom to be 1 after resizing. Nice. All right, so let's tackle UI. We actually want the available height to be less than the actual available height on the screen. We kind of need to change things up a bit because we are using render height everywhere, but that's not really how things go. We will probably need something like available height. Let's have something like title bar size. And title bar size is basically something like, let's say, 50, right? And we will then need to do something like vec2s available image size, or like letterbox. Let's just call it letterbox because we're like very cool. Okay, so let's have letterbox be s.render.render width and s.render.render height minus basically s.title bar size. And then we are basically using, let's see, s.render, let's name this something like W and H for now, because we want to say s.render width is now s.letterbox.x and s.render height is s.letterbox.y. And this is s.render.render width and s.render.render height. Let's see what this yields. Yeah, this yields that. But I'm kind of wondering, we probably also need, let's have something like this. I think this is the best way of putting it. Okay, so this basically creates space at the bottom, right? But we want that space to be at the top. meaning that we also want a position for the letterbox. Okay, let's say letterbox y is equal to 30, and then we would say something like is equal to like letterbox y plus all of this. Okay, now we basically have this kind of letterboxing, but we want to say something like 50. Okay, perfect. And now what we can also do is to not have this y because it's not that cool. We want to have something like AABB, and we actually do it like this. And we have a pos and a size. So let's have it at, let's have letterbox.x be letterbox.size.x because we use it as size. Letterbox.y is letterbox.size.y, and s.letterbox is equal to AABB dot size is equal to the size that we were using. s.letterbox.size.y, but this is not actually what we want. So let's just have it like this for now. This just yields that, okay. And then we can actually start saying .pos.y and s.letterbox.pos.x. And let's split those lines quickly. So yeah, this, and then we want to say .pos is equal to vec2s 0 and s.titlebar size. And then we can actually, I think this is good for now. Nice, okay. So just like that. And then we can also kind of have something like title bar size and then like scroll, like gallery scroll size. And this is going to be gallery scroll size. And then s.gallery scroll size maybe like something like 80 because we're going to have the gallery down there. And then we have more space like here. All right. Now that we have attained our space basically for the UI, let's actually write UI. So let's just start by rendering a text, and the text is actually a close icon. So let's open up Firefox and go to NerdFont cheat sheet, and then let's search up close. This is the best close icon, by the way, so let's use that. So close, and the font. Okay, so what we're like to make this more user friendly, let's go to JetBrains, or actually we're going to use the Inter nerd font. The font downloads, I think there's an Inter nerd font. No? I was pretty sure there is. Inter nerd font. Yeah, perfect. So let's just copy this repo. I think it's probably cool repo, right? Let's git clone that. And yeah, perfect. And then we can say we want, let's get actually rid of that and that. Let's actually say we want our font, right? So let's have a something like font large, font medium, font small, right? Like every good UI developer. And then let's say s.font large is equal to rnload font s.render dot slash internode font slash inter, and then like the so why complete? That's a little bit weird. Yeah, let's load the bold font for the large one, and let's have our large size be something like 35. And then font medium is going to be 24. And let's have it be inter regular. And a font small is going to be regular at something like 18. So let's write a close sign with s.font large and vec2s. Yeah, we probably should introduce something like padding. So let's have padding, and color is going to be black. So let's see, now we have a close icon already, and it looks like an actual app. All right, nice. That's actually great. I think we would probably want something like a simple like function that can render a icon or like a UI element. So let's actually have that. Let's have a x cursor is equal to padding, and then this function that I was talking about, let's call it, actually let's also kind of exit out of here. Let's call it void render UI element, and it's going to accept a text, and we're going to be using text. Oh, I need to kind of keep that. So let's keep that. So text, and then it's also going to accept a font, obviously, and it's going to accept an X cursor, right? So X cursor, and we probably want the text to be centered in some kind of container on Y. So we probably want, yeah, we also want something like float Y, like container Y, and float container size Y, because then on the scroll bar they are all like centered relative to each other, and it looks very good, because then otherwise they would all be at 0, 0, like at 0 Y, or like the same Y. So this is definitely better. And the X cursor is actually like this, and then let's have it at X cursor and at yeah, the size basically. So let's have an rn text props. Props is equal to rn text props of the render state with the given text and the given font, and text and the given font in here as well. And then we say basically container pos Y plus container size Y minus props.height divided by 2, because this is basically centering, and here we basically offset to the container. That's that. And then we can say x cursor plus equal props.width plus padding, and we basically want to specify padding here, or kind of not, right? Let's not do that. So let's have a padding given, and yeah, let's see. So let's have padding be that, and rn, it's actually not rn, it's render UI element. The why is it what? Because okay, so this font is going to be s.font large, and this is going to be the X cursor. This is going to be padding. This is going to be s.titlebar size. Yeah. Actually, as the title bar size plus padding. This is padding. But not really, right? Because we are not calculating that in anywhere else. I think what we want is this and have this be at 0. Yeah. All right. Because we are not calculating in padding for the letterboxing, so we basically want to have it centered from 0 to title bar size, which ends up here. Nice. Okay. So every UI element should have a like on click, right? So let's implement a on click, but for that I need to kind of find a function which is very useful, which is point in AABB. Let's just copy that. But it uses min and max. So what do? We basically, yeah, just convert them. So let's say box.pos.x and then box.pos.x plus box.size.x and box.pos.y, box.pos.y plus box.size.y. Just like that. And now we can check if a point is in an AABB. And I think this definitely should be somewhere on up top. And what we then can actually also do is we can check if point in AABB, vector s, cursor x, cursor y, if it's inside the letterbox actually, right? But not really. Like, it would be cool, but no. We actually want to check if it's inside the image, right? So let's see. We have cal pos. This is basically the displayed pos, and then if not in ABB, dot pos is equal to displayed pos and dot size is equal to s dot image size. And if that's not the case, we want to return because we don't want to zoom in if you're not even on the image. And it didn't work. Nice. So why did it not work? Okay, so what I just did is basically the letterbox. We added the title bar size to the available width subtraction, because obviously we also have the title bar and that's not factored in. So now it's factored in. And then after we calculated position and size for rendering, we want actually the letterbox to be the render width and render height letterbox for the zooming. Because if we didn't do that, then the zooming would be offset, which is not correct in because we are also using the absolute cursor position. So now we basically have this letterboxing where we always have this space and everything is basically working fine. So now let's actually add another, or basically not another UI element, but actually change our or make our logic better, like the UI element logic. Okay, so we definitely want some kind of hovered state, right? So to get hovered, we can just check if point in AABB, vec to s, and then we just need to get mouse x, mouse y. After we get cursor position, window, mouse x, mouse y. And yeah, okay, we don't have window. So let's actually say everywhere where we use window. Yeah, that's kind of hard. Add s.window and then have a GFW window. S.window. And we will check if the mouse x, mouse y intersects the AABB, which is dot pos is equal to vec to s Yeah, I think we can get this basically. So vector as item pos is equal to this, and vector as item size is equal to vector as props.width plus, yeah, we want to probably add padding in, so plus padding, and then props.height plus padding. But the question is if it's padding times 2, but not really, because we are also positioning ourselves at padding, so this should be good to go. Let's see, so we have item pos and item size, and have item pos right here. And then we say if hovered, we could say something like rn color displayed color is equal to rn black. So rn black, and then displayed color is equal to let's get some cool color picker color. Nope. No, you didn't do good, random generator. I think some kind of blue is cool. Something like that, because we're also in white mode, so we have to have something a little bit more dark. So rn color from hex, displayed color, and then we say displayed color when we are hovering. So this window, interesting. This is not something we want, okay. And we don't need this as well, so let's have that and that. Okay, nice, we can hover. Actually, we can hover, right? But the plus padding thing is kind of weird, right? I think we are not really taking padding into account for the displaying, so let's also not take it into account for the checking, because now, yeah, it's definitely better. Okay, but now for actually correctly getting like handlers, right? What we kind of want to do is we want to have a state, or first of all, we want to have a pointer function. I can't remember C pointer functions. I always have to look that up. Something like that, right? So let's see. Click handler just takes in void because we're global. Click handler, active handler, or like, yeah, something like active handler. And because then we can correctly have the handlers based on what you were trying to click, and not like based on what you're currently on. Because then when you have something like you click a button and then you drag away and then you release and then the other button gets clicked and stuff like that, we just want an active handler which gets assigned when we click, and then when we release the mouse we just call the handler if we're still on the button, right? Okay, but let's actually have something like click handler, and let's check something like if, but first of all, we also need bool mouse down is equal to, if we get mouse button with s.window and gfw mouse button left equal gfw press. And yeah, and then we can basically check if mouse down and we are also hovering, and not as .active handler, but we probably want something like if handler. Then we say s.activeHandler is equal to handler, right? And then if we have not mouse down now, so let's actually have it as an else. Yeah, why not? We have it as an else if, so, and we have an active handler, and we are still hovering. Then we want to say, but actually, let's not have this, because we are actually saying something like as active handler is equal to null when we are pressing away, like when we are like releasing. We also have to do it when we are not on the button anymore. So let's check if hovered and so if hovered, then we want to call the handler and also post an empty event, okay? So that we are waking up the loop after we have consumed this click event, because there has happened something else again. So now we can actually specify the handler. So let's have something like void close handler, and then GFW set window should close window s.window true. And then we say we have the close handler here, and it's incompatible. So what do we have here? So void, right? Perfect. Okay, and let's try clicking away. Okay, nice. Yeah, okay, it works, right? Now let's implement full screening. Let's go back to NerdFun cheat sheet and say something like maximize, maybe, or full screen. Yeah, I think this one was cool. Like that. So let's have this button, right? And they, okay, what? The flip. I already have the inter nerd fonts, so I'm just going to copy the actual font. So user share fonts inter dot, and then we're just going to use inter slash. I think this should fix this issue. Yes, nice. Okay, but I think the full screening button kind of is weird, you know, because it's like overweighing the actual closing button. Maybe we could say something like font medium for the full screen button. Yeah, not really, right? I think, yeah, this is kind of good enough. It's not even that bad, right? Okay, nice. But let's actually implement set full screening. So what we will need is something like avoid set full screen. GFW already makes this pretty easy. We can just get GFW monitor mon is equal to GFW get primary monitor, and then const GFW video mode or vid mode is equal to GFW get video mode of mon. Okay, and after getting video mode and monitor, we can say GFW set window monitor, and then we will use the monitor 0 for x, 0 for y, and then the video mode with mode.height. Refresh rate will be mode.refresh rate, right? Refresh rate. Okay, and unset full screen. We basically set so unset full screen. We set window monitor to null. So s.window null null, and then we revert to our 640 by 480 at 0 refresh rate to handle it, to let GFW handle it, right? And then we want a void fs handler, and then if, and then we need some kind of state of full screening, right? So bool full screened, or like maxed, if s.maxed, unset full screen, else if like s dot, and then else we set full screen, and we say s.max equal to not s.maxed, but we want then this to be not s.maxed because we have already flipped it. So let's say fs handler, and let's also say s is equal to global state 0. Let's see. So full screening perfectly works. Nice. Okay, but I think we definitely also want the image to then be full screen, right? I think what we can actually just do is to have, we can have this be max. Yeah. This basically full screens the thing. Okay, so let's say s.maxed, else like that. So let's see. Okay, and then we probably want the buttons to like not be as weird, because we want to say something like if not s.maxed, render the entire title bar, and else we want to only render this first of all, but then also we want something like bool filled, because we don't want it to be drawn on like empty background. So if filled, then we want rn white, and else we want rn black, and then we say rn rect render. We definitely want item size to be plus filled question mark padding, 0, but it's probably going to be ×2, yeah, because we also want this to be plus filled question mark padding, else 0. Okay, so this is that. Then we want to rect render. If filled, we want to rect render with s.render at item pos, item size, rn black. And here we say filled is false, here's also false, and here it's true. Okay, so obviously we kind of have this item pos is the position of the filled container, and then the text needs to be vector s. No, it's not that. It's here. Vector s item pos.x, and then plus filled question mark. Okay. Then also the item size definitely needs to be filled ×2 question mark. For what the fuck? It's padding ×2. Filled ×2. That's really insane. Okay, finally. Now we probably also want the rect to be cool and smooth, so let's ex that motherfucker. I probably going to have to beep that out because I'm monetized now. Or no color. Corner radius, let's have a corner radius of 10. Nice! We have full screening. And we have zooming, so I think we actually yeah, kind of good to go, but yeah, we kind of could add rotating and stuff. So let's actually yeah have another UI element, which is let's just call it image.jpg for now, because it's going to eventually like show the actual file path of what we are actually looking at. And let's have it a medium font, X cursor, title bar size, and basically it's going to have no handler. Okay, I think the medium font looks kind of ass, so let's have it as regular. And let's also have padding at 20, I guess. And let's have this be at 20 and 16 or something. I think padding at 20 wasn't the best move. And also this should probably be something like 23 and this should be 19. And then padding is going to be 15. Yeah, looks good, I guess. This actually looks good. And then what we want is also another text, which is just going to show the size of the thing. So let's have something like this. Yeah, nice. But I also think this should be font. I also think, just as you, man. So I also think, bro, I I think this should be font small. Yeah, that actually looks kind of aesthetically pleasing, I would say. Okay, we can hover that. That doesn't really make sense. Hovered and not handler. And handler. Like that. And then what we basically want is the other side of the UI. I think this thing is kind of dumb, so let's not do this. Let's just keep it like that, but say something like cons like char file path buff is equal to that for now. But this is like dimensions buff, dimensions buff. And then we say rn text props of s.render, text being dimensions buff, font being s.font small dot width. Okay, so this is size right of file path. And then we can actually say rn set cull end x to so we want to cull at s.render first and then s.render width minus the size right of file path. And this is not only that, but also plus padding times 2. So basically like that. And then we're going to be rendering the elements normally and just unculling again after like that. Okay, we don't want to include experimental file system. Okay, cool. So this works, but then we want to say that the x is basically going to be float x before is equal to x cursor. Okay, we want to actually check if the x before plus text width is greater than or equal to the cutoff position. Then we want to say x cursor is equal to the cutoff position, basically. So like that. And then we add padding to make it not cut off immediately. And also add padding to that, because it's not padded yet. All right. Yeah, now the question about the... We probably want is equal to, let's say, float size left of file path is equal to 0, and then size left of file path plus equals that, size left of file path plus equals that, and then we say is equal to this, and then like max size left of file path, but also plus something like 50, so that the text, yeah, 50 probably just accounted for the padding now. So let's do this. Okay, interesting. Because I think we definitely have to do one padding, but then this basically should be the cutoff position. So float cutoff is equal to that, and then we say cutoff, and we say it's equal to cutoff. Yep. Then also it should be plus padding here. And where's the plus 50? Let's say plus 80 or something. And this has to be plus padding, and this has to also be plus padding. Okay, now we want UI elements that are at the right. So let's have a Firefox, not from cheat sheet. Let's have a rotate. And this is going to be font large. And then we basically say x cursor space right is equal to rn text props as rn s.render with this, and s.font large dot width plus the folder. So let's take that folder plus this width, but let's say plus padding. Yeah, then x cursor is basically equal to s.render.render width minus space right, and then we render the both UI elements. Let's see. Okay, and we want them to be basically x cursor is equal to max the current x cursor and this. So we don't want to, yeah. That's basically the best we can do, right? Okay, so this is basically the title bar, right? We can click the things, and we don't really have handlers for this yet, but we can kind of implement them, right? For example, we could say we have a rotate handler, and this just has something like rotation, and the rotate handler would, in this case, just change the rotation by 180 degrees. So where do we have the handlers here? Let's have a rotate handler. This just does s.rotation plus equal 180. Or if is equal to s.rotation equal 0, 180, else 0. And then we are going to say rn image render ex, and this now takes a rotation angle, but no border color no border width and no corner radius. I think it's something like something like that. So rn texture, border color, border width. So like that, and it's going to be s.rotation, right? And this basically then takes the rotate handler. Perfect. Rotating la image. Nice. Okay, now that we have the basic functionality done for the UI and shit, we can actually implement all of the real systems. Like, for example, I'm going to start with the system that will asynchronously load the image data. And what we are basically going to have is 2 stages. So currently we only have stage 1, and stage 1 is just on the main thread, and it does STBI loads and basically blocks for that and waits until it's finished. And then it does GL text image 2D and uploads it to the GPU. And this is basically for one texture. So, and this involves this step. But what we want is stage 1 being on a separate thread, so on a thread worker, and it calls STBI load. Just that. And it doesn't block. It just does that, but it does that asynchronously. All right, so that we can load many of them at once. And we will have 16 thread workers or something, and they're all going to load separate images asynchronously while not blocking the main thread. And then in stage 2 on the main thread, we are basically going to collect all the loaded images and then call geotext image 2D with the data that we have collected. And this happens on the main thread, and it's really fast. This just doesn't really block the main thread. This is what blocks the CPU because it's the CPU work. And we're basically going to have to implement a thread pool and a submission queue to push to. It's going to be fun, right? So let's actually do that. We are actually going to modify Runara for that because textures now have a state, right? So let's have a typedef struct rn texture state or loading state, and it can be rn text loading to 0. That's basically the state. It's not a struct, by the way. That's basically the state when we are currently inside STBI load and the texture is being loaded. And then we have STB, then we have ready, basically. And we can also have failed when for some reason we were not able to correctly load the texture. And ready is just that the loading is done and we can use this texture data in OpenGL to upload it, right? And yeah, then let's have a rn texture loading states per texture. And this is just the loading state of the texture. Yeah. Okay, that's basically that. And then what we also want to store is a file path, because then we can easily check what kind of file path belongs to what texture, and we can basically load textures with file paths that and basically immediately link file path to texture, which is going to be very important for displaying the file paths and stuff like that, because you want to display the file paths, as you know. Okay, that's basically it. That's what we kind of want to have. And this is now the stages. All right, so let's start by creating a thread worker that just loads with STBI load. Okay, but for that, let's have a typedef struct loaded texture data, which is basically the thing that we're going to submit into the queue. And it's basically what is being returned from STB image, which is the data. So uint8t pixels, let's call it pixels. And it's also a int32t, more like a uint32t width, height, and yeah, and what else? I think what we definitely want is to actually have a texture pointer so that we can correctly assign texture IDs to loaded data that also were linked with a file path. So we basically link file paths to textures and textures to loaded texture data. All right, so let's have this, and then let's have somewhere here, let's have a void load texture worker, and it's going to be having an rn texture, and the texture is just basically used as the pointer because like that's the thing we are going to be referencing in the data, so in the loaded texture data. Image is equal to loaded texture data dot texture is equal to text. So this is basically what we're going to be doing. But before that, we definitely need something like int32t width, height, and channels, right? Because we're going to be loading with STBI load. Actually, we need to include STB image. So let's include it from Runara. Vendor, STB image.h. And then let's STBI load text.filepath with width, height, and channels. And also STB, I think RGB alphas. Yeah, that's definitely what we want. And then we're going to be having the pixels, right? Let's call it pixels. And then we can just assign, right? So width is equal to width, height is equal to height, and pixels equal to pixels. Like that. And then we can also check if not pixels, we can say texture state is equal to rn text failed. That's actually kind of good. And like not good, but it's good that we can implement that. And then what we basically want is to submit this data into the image queue. And the image queue needs to be basically mutex and thread safe. Like it's going to use mutexes to be thread safe, and it's just a simple queue that is just using a mutex. So let's call queue push basically into like something like image queue, the image, and let's implement queue push, right? So for that, let's have a queue node. So queue node or image queue node, it's basically going to have the loaded texture data, and it's going to have a image struct image queue node next. Can I do typedef struct? Can I do this? Yeah, right. So it's basically going to have that. And a real like image queue is just going to consist of a mutex and head and tail. So let's have a image queue node, head, tail, and the pthread mutex t mutex. And it's going to be the image queue like that, and we're going to have image queue. And then let's have after that, let's have a queue init. It's going to take a image queue, and it's just going to do queue.head is equal to null, queue.tail is equal to null, and importantly, it's going to pthread mutex init. Hello. Didn't we include pthread? We didn't even include pthread, man. What a shame. Queue.mutex, no. And we can have to pass that as a reference. So that's initializing the queue, and then queue push is just a simple linear like list, linear linked list push. So we're going to allocate the node. So n is equal to malloc size of n times times nothing. I'm thinking arrays, man. And then it's not an image queue we want to allocate, it's an image queue nodes. And then n.data, we also want to push data, obviously. So data is equal to data, and n.next is equal to null. And then we want to basically lock the mutex and add it to the queue. So mutex lock queue.mutex null. I think you lock that like this. So, and then pthread mutex unlock the mutex after that. And then we just check if the queue.tail, then we say queue.tail.next is equal to n. From image queue node to, oh yeah, I think this is a problem, yeah. I don't really know how to fix it. Can I do this? Can I do image queue nodes, image queue node, and then struct image queue node and struct image queue node, and then like this? Yeah. Okay. Yeah, we basically add it to the tail, right? But if we don't have a tail yet, we can say q dot basically we say q dot head is equal to n, and then q dot tail is equal to n to correctly add it to the back of the list, basically, right? That's the queue insertion, and that's also it already. And then we can actually also implement popping from the queue. So queue pop, and it should return a bool, because if the queue is empty, then it should return false, so that we can actually do it in a while loop in the main thread, right? So we want an image queue, and loaded texture data, all data. Because we are basically popping the last loaded node and getting the data from it. And if there's no like loaded nodes, this is such a, I can't even say the word loaded node. Then we want to just return false. Okay, so let's actually call that queue. So we want to lock our mutex and unlock our mutex, and then we can just check if we don't have a head. then we are empty. So then we definitely have to unlock to avoid stat locking and return false. And here we return true. And then we just pop by doing, I think we want image q node n is equal to q.head, and then we say q.head is equal to q.head.next, or basically n.next. And then we also need to correctly say when we don't have a head anymore, we also want our tail to not be there. So if this made this empty, then obviously the q.tail is also null. And yeah, and then we can just say data is equal to n data. And then we want to free n, right? And that's basically popping from the queue. And then we can uncomment this, and we actually have our load texture worker, right? Okay, now that we have that, we actually need our thread pool, right? So let's go back onto here, and let's have a type def struct thread pool. And our thread pool is just going to consist of all of the threads that we can have available. So threads and un32tn threads. And it's also going to basically iterate through all of the jobs that have been submitted. And we do the submission in a linked list. Basically, exactly the same linked list that we had for the image queue. So let's just have a type def struct job node, and struct job node, and we're going to have a job node pointer next, and and then basically a job callback, and the job callback is going to be basically a where do we have our this? Yeah, we're just going to be having a job callback which takes in a void pointer argument, and it's basically each job has a job callback, callback and a void pointer argument, so that we can basically on submission we store the argument, and then on execution we call the callback with the stored argument. So let's have a job node pointer head tail, and then let's have a pthread mutex t mutex again, and now we also want a pthread cont t condition to conditionally wait when there are no jobs, and also we want a bool stop to correctly clean up the threads when we have shut down. And what we basically want now is a worker that is going to be continuously running and waiting on the condition. And if it sees a new submitted job, it's just going to execute the job. And yeah, that's basically that. So let's have a void thread pool init first, right? So it's going to take a thread pool. And for thread pool init, what we basically want to do is init and also end threads, right? Because that's kind of important. We want to init un32t I is equal to 0, I is less than end threads, I plus. I'm wondering if I should do that probably after, yeah. So before that, let's do pool.tail is equal to null, pool.head is equal to null, and pthread mutex init pool.mutex null and pthread cond init pool.cont null. And then we say pool.stop is equal to false. And what do we have else? Pool.endthreads equal to endthreads. Pool. Yeah, that's basically all we have. Let's say endthreads and basically say pool.threads is equal to malloc size of pool.threads times endthreads. And then we say then we say pthreads create new thread is going to be pool.threads at I. This is null. And then, yeah, this is going to be having the thread pool worker. So thread pool worker. And arg is going to be, yeah, we can pass the pool itself as an argument. I think that's the good engineering choice. Okay, so that's basically our init. Let's quickly implement a thread pool submit, which is also just a linked list append. So let's have a thread pool and a job callback and a void pointer arg, as I said. And then we can actually just copy this, right? Not this, but this. It's literally the same thing. Just that we have a job node n and n.arg is equal to arg. What the fuck? No, we are in the wrong fucking function, man. Here. So job nodes, and this is going to be n.arg is equal to arg, and n.callback is equal to callback. And this is not q mutex, but pool mutex, and this is pool. Then we want to signal the condition, right? Because we now have a job. Oh my fuck. Pthreads mutex. It's not mutex, it's cont signal the pool.cont. We have to do that before unlocking. So this is the submission, right? And then the worker is going to just while true pthread mutex lock. Yeah, and then we basically need the thread pool is equal to arg pool dot mutex, and then pthread mutex unlock pool dot mutex, and then we say while we don't have a head, and we also don't want to terminate, we will just wait. So while there's no current job, we just chill, right? So the pool cont, and I think this needs the mutex. Let's see. Yeah. Pool.mutex, right? So this is basically waiting for the new jobs. And then we just consume the jobs. It's basically also like the popping. Yeah, and then if we also need to check when So let's do job node n is equal to pool.head, and then pool.head is equal to n.next. If not, pool.head, pool.tail is equal to null. And then after unlocking the mutex, we want to basically say free the node, but before that, we should probably say something like n.callback, n.arc. All right. And also we should probably say something like pool.stop. Then we want to unlock and break, so that we end this function. And this should return null. Yeah, and this is basically the thread pool, right? So now we could have a job callback, which takes in just that. Okay, so let's have a. Oh, wait, where's our no texture? We kind of need a. We kind of should do something like void pointer data, and then like rn texture text is equal to data, and then we can use that worker immediately. And let's try to just use them. So let's go into here and let's just say something like thread pool init pool. And by the way, let's just first do that. So I just noticed we need thread pool shutdown. That's pretty important. So thread pool, and it's just going to basically join the threads and stuff. So let's have pool.nthreads, pthreads join pool.threads at I, null, and free pool.threads. And also we definitely want to lock the mutex to signal the condition. So pool.mutex and unlock. And this time we have to conditional broadcast. So broadcast just signals to all threads that are currently waiting, not just to one. I'm so dumb. Cont broadcast, right? So cont broadcast pool.cont, and this is going to be pool.stop is equal to true. Do we need anything else? I don't think so. So let's have let's actually have a thread pool. Yeah, before that, let's have a thread pool. Thread pool. Let's have a thread pool init s.thread pool, and n threads. Let's have n threads be at sysconf, and sysconf, we need unistd for that. So sysconf sc and processors conf. I think it's that. -2, so that we just spare 2 threads, because yeah, you know what I mean. So we basically, we want to init with those threads in the thread pool, and then we want to say pthread thread pool submit to s.thread pool, load texture worker, and arg is going to be rn texture pointer. Text is equal to malloc size of text, and then text.type is equal to stirred up mountain.jpg. And as an argument, let's pass texture. So yeah, this should load the texture. And then let's just say thread pool shutdown s.thread pool. Okay, failed to load texture at. Okay. I know why. Because this is a really dumb issue. Because let's go into Runara and make again. Because now we changed the header file, which means that the size of the texture has changed, like the struct size, but the internal file, like the runara.c, has a different struct size, and it's just a big mess. So we definitely have to remake after changing the header file. All right, so I think it worked, right? So let's see. stbilo. Let's see. Printf loaded texture text.flat. All right, man. I think that actually worked. Yeah. That's great. That's actually very, very good. Now we kind of want a like the stage 2, right? So this is stage 1, but stage 2 should be the collection, right? So let's have collect image data to GPU void, and it's going to basically do something like while qpop s.imageq, and then like loaded image data, and then like loaded texture data, and then add data and imageq, and we are going to say then we want to gen the textures, right? So let's say rn texture, because now this is actually good, because now we can say something like rn texture text is equal to image.texture is equal to data.texture, and yeah, and then we can gen for the texture that we have stored. So let's gen text.id, gl bind texture, gl texture 2d, text.id, and then let's copy the filtering code and stuff like that. So gl text parameter. Yeah, we want this and this. Okay, so text ID, and this need to be texture parameter I. Oh, okay, let's just not do that, right? So text parameter I. And then I think, yeah, this needs to be texture 2D, texture 2D, and yeah, and then we want a text image 2D to upload the data. This is so easy in OpenGL, right? texture 2D, level 0, internal format, RGBA 8, I guess. Or just RGBA. I think it's just RGBA. And then width is just very easy. Data.width, data.height. Border is 0. Format is GL-RGBA. Type is unsigned byte. Pixels is image.pixels. Is data.pixels. So easy. And then we generate map maps with just one fucking command. I think we have to include glad for that. Include glad. OpenGL had already included. Okay. GL generate map and yeah, then we want to say text.width is equal to data.width, text.height is equal to data.height, and text.state is equal to rn text state ready. Rn text ready, okay. And then we can actually also free the STB data that's now on the GPU, so data.pixels. Yeah. What we should definitely have is something like a very simple something like a very simple queue constant entity max uploads per frame is equal to something like 4, because then if we don't do that, frames will drop because it's just loading on all threads, and like we have per frame maybe 16 images loading, and then everything is going to load in one thread, and we basically don't really want that. So let's just pop only 4. So let's pop and then say something like uploads is equal to 0, and uploads is smaller than max uploads per frame, and then uploads plus. Yep. Okay. And then we can actually say something like s.image will now be a pointer. So let's have s.image and then dot with s.image like that. And then let's say s.image is equal to s.image. Okay, so I just created a loading PNG. It's just an image, right? So let's have something like rn texture loading placeholder, and then we can say, and yeah, then we can basically say collect image data to GPU, and then if s.image.state equal ready, then we want to render this image, or basically let's say s.image.state equal on text ready, else s.place loading placeholder.id, and then s.loading placeholder is equal to rn load texture with ./loading.png. Yeah, let's just have that. Also, what we definitely want is in queue push. After we push, we want to post an empty event, right? So that we are going to wake the main thread. Okay. Segmentation fault. What the Alright, so we are posting an empty event when we push to the queue, but I think we also need to post an empty event when we didn't correctly like free all of the items in the queue. So if s.imageQueue.head is still there, then we want to post an empty event to reactivate our senses. Okay, but why is the thing still not working? All right. Nice. Okay, so we are loading textures basically, right? So let's now actually be productive and let's get a cool thing, which is actually let's copy -r def, which is the example image viewer that I showed in the beginning. Those are a lot of anime girls, okay? And we basically want to read the directory. So a read directory is going to take in a dir. And I think I kind of know how that kind of also works. So what we basically also want now is an RN texture gallery, right? So gallery images. And the gallery images will consist of the images inside a given folder. And we will say something like image cap is equal to 64. And we say s.gallery images is equal to malloc size of s.gallery images times image cap. And yeah, that's basically that. And then my question is, we probably need something like full path. This is like path max. And then we will also need something like OpenDir. And for that we need the rent. So OpenDir /c. This is going to be returning a dir. And if we didn't manage to open the directory, we're just going to return for now. And then, yeah, then we are basically doing while. So we're going to be cool and assign inside the while is equal to read dir dir. If that is not equal null, so while we can still read directories, we want to say something like sprintf full path, and then like %s, and entry has a dname, but dname is only the name inside the directory, so we have to do basically something like, yeah, let's have something like dir path and dir path in here, and then we print to that. And we also want to skip if string compare entry.dname dot equal 0 or dot equal 0. So basically, because they are also listed, then we want to say continue like that. And then we check for if stir full path dot png not equal null or stir. Yeah, that's like a German reference. Probably won't get it. So for each JPEG and PNG file, we will malloc a texture, right? So let's say rn texture text is equal to malloc size of text, and then text.file path is equal to stirred up, and this time we'll take the actual full path, not just some random ass path. And we say text.state is equal to rn text state loading. Rn text loading. And yeah, and then we also need to kind of say s.images or gallery images at s. Oh, definitely need that. U entity n gallery images at s.n gallery images plus plus is equal to text, and then if s.n gallery images is greater than or equal to image cap minus 1, then we say image cap times equals 2, and s.images gallery images is equal to realloc s.gallery images size of s.gallery images times image cap. So basically expanding, and yeah, that's that, right? Oh, okay. So yeah, that's basically us loading all of the images in a basically in a directory. And then we can also say s.image is equal to, wait, we definitely need to do something like this, and then s.image is equal to and s.loading placeholder. Okay, and then we will have s.image.id normally, and then we basically want to say something like if s.image is equal to placeholder, then we want to say I is equal to 0, I is less than s.n gallery images, I plus plus, and then we just check for the first loaded image. So if s.images gallery images actually at I and s.gallery images at I dot state is equal to rn text ready, then we say s.image is equal to .id is equal to s.gallery images at I.id, and s.image.file path is equal to this file path, and then we break. Okay. Yeah, this should actually work. Okay, so it didn't work, but let's actually do an stbi load. Let's say loaded texture. So it's not loading anything. That's great. We're not even submitting, man. So let's have thread pool submit s.thread pool loads texture worker and text. Yo. Would you look at that? That's actually great, right? That's actually great. Okay. Now we can actually render the like the scrolling gallery, right? So let's do that. Okay, so let's actually have something like float case of padding is always 10 or 15 or whatever, but let's have something like gallery pos is equal to vec2s. We're going to start at padding and s.render height minus the s.gallery scroll size. It's very misleading, like very misleading. Gallery, I don't know if you even write gallery with a double L, but that's not, we're not a linguistics class or something. So scroll layer size, gallery size is equal to vec2s, s.render width minus, now comes the question, right? Minus padding times 2, because we already subtracted padding. And this is going to be s.gallery scroller size minus padding times 2. Then, yeah, this is the gallery size. And then we want to basically scissor that and stuff like this, right? So let's have a rn set call start x s.render gallery pos.x and end x gallery pos.x plus gallery size.x and start y and end y and then we want to unset all of that again, and then we want to draw all of the images. So I is equal to 0, I is less than s.n gallery images, I plus plus, rn texture image is equal to s.gallery images at I, and then we want to check something like is ready question mark, but not really question mark, we have to assign it. So image and image state is equal to rn text ready. So this, and then we basically say rn texture rendered image is equal to is ready image else as the placeholder image. Okay, and yeah, and then we basically want the images to be scaled correctly to the like the aspect ratio needs to be correct to the size, like the height of the like the gallery, right? So we kind of want something like scale is equal to gallery size dot y divided by float text rendered image dot height. Yeah, and then we're going to have something like vec2s image size is equal to vec2s text dot width rendered image dot width times scale, like the scale adjusted to the gallery size, and then gallery size dot y for the height, because we're adjusting for this height, right? And yeah, and this is like the image size, and then the image position. For the image position, we will have to have something like x is equal to padding, and the position is going to be image pos is equal to x, and for this we're going to have gallery pos.y. All right, so let's render the image. I'm going to use ex because later we're going to do some cool stuff with borders and shit. So image pos 0, rn white, and then rn texture dot id is equal to text.id is equal to rendered image.id dot width is equal to rendered image dot width dot height is equal to render image dot height. No, that's actually not true. It's image size dot x, image size dot y, because obviously we have scaled them. So let's do this. And then we will say something like if x plus image size dot x plus padding is greater than or equal to basically gallery size, right? No, not really. We want basically something like this: minus padding, break, and x plus equals s plus equals image size dot x plus padding, right? Yeah, this is basically us rendering the gallery. Yo, would you look at that? We have a gallery. This is really cool. What about gallery size being too small? Let's make 150, man. Yeah. I think this is too big. Let's say 130. And also, yeah, it is correctly. Yeah, that's actually very nice. Okay, man. Or like thing is working correctly. What is it called? The thread pool and all of that is working correctly. I think the next thing we definitely want is the gallery to be scrollable. Okay, we will need some variables for that. Let's have a float scroll offset, which is the gallery scroll offset, a vec2s scroll grab. I think it's actually just going to have be a float because we don't care about the y's grab, like the y grab, and then a bool dragging and a bool mouse pressed. Maybe that's it, right? And then in the gallery scroller code, we definitely need to obtain our mouse X and mouse Y. Do we have some mouse X, mouse Y work already going on? No, not really. Okay, so let's have mx, my, gfw get cursor pos, s.window with mx and my, and yeah, and then we can check if the mouse is down. Don't we? I really think we already have that. Yeah. Okay, so mouse down is that. And then we can basically check if mouse released, right? Because then it's just not mouse down and s.mouse pressed. And yeah, and then also a thing we fundamentally have to check is are we actually inside the scroller? So inside scroller is equal to point in AABB, and you should probably know how this would be done. Just checking if the mouse is inside AABB. Yeah, let's do that after that definitely. So if the mouse is inside AABB, gallery pos and gallery size. Then we are inside the scroller. Okay, so let's check if mouse down, and we haven't yet pressed the mouse, and inside scroll region. Then we want to basically start tracking where we have grabbed. So grab is equal to yeah, I think we should have something like that. So vec2s mouse or something. Mouse is equal to this, and then mouse. So strap is equal to mouse, and yeah, and then we can say s.dragging is equal to false, obviously, and s.mouse pressed is equal to true, and oh yeah, thank you, man. Let's just say mouse.x. Yep. And then if mouse down and we have arm pressing the mouse, this means we are currently like probably dragging, but the probably is kind of dumb. So what we want is we want to check the distance between mouse.x and s.scrollgrab, and if the distance dx is greater than, let's say, 5, then we want to start dragging, because this is basically, this just prevents dragging when we just want to click, you know, because we also want to click on the images. And then we can check if we are dragging, then we just say scroll offset is equal to mouse.x minus the grab.x. But actually this is just local, so it's not taking account of the scrolling we already did. So we also need to have something like last offset. So s.last offset plus that. And then we can check if mouse released, and then s.last offset is equal to s.scroll offset, right? And s.mouse pressed will be false, right? When we release the mouse. And also s.dragging is equal to false. False, man. This is when we release the mouse. Scroll offset plus padding. Let's check what that does. Yo, first try. But now the problem is that we have this basically. So we have to figure out what is the max scroll. All right, so to figure out what is the max scroll, we can just copy this and say something like float max scroll is equal to 0, and the scrolling is to the left, so we actually have to say minus equal the image size.x plus padding. And then we also have to plus equal gallery size, because this would just yield the position of the last thing, but this would make it so that we can scroll past the last thing what we want to scroll, so that the last thing is at the right, meaning we have to add gallery size, right? Yeah, and then we can say something like x. Yeah, let's just do it like this. If x is less than max scroll, and then we say x is equal to max scroll and s.scroll left is equal to max scroll, and else if x is greater than 0, so we go to the basically too far to the left. Yeah. Then we say x equal to padding and s.scroll is equal to 0. Easy, man, easy. So we can't scroll to here anymore, and can we scroll to here? No. Nice. Clean, man. And resizing and stuff works correctly. All right, so now we should oh. Yeah, I think no. I was just imagining some random problem. I think what we should definitely do is add some fucking ass rounding to that motherfucker. Right? Let's add 15 rounding. Like that. Perfect. And yeah, then basically we want to check, are we on the image? If yes, we want to store the clicked image, and then on mouse release, we say that we want to update the image. So let's say clicked image, image pos is equal to, so bool on image is equal to point in AABB, mouse AABB, image pos, image size. So this is on image, and then if we are on image and the mouse is down, and we have clicked image is equal to -1, and by the way, yeah. And we are also not dragging, very importantly. And then we want to say clicked image is equal to I. And yeah, and then here, let's have some kind of helpful function called update image. So void update image. And update image is just going to say UN32 or like RN texture new image. And then we say s.image is equal to new image. Calc ratio letterbox. Probably also need something like index and then because it's actually kind of important. Image index. S.image index is equal to index. And we also want to post an empty event. Just for good measure. And then in here, we also would need to say something like s.image index is equal to I. And then we will have, where do we have mouse released? Then we will just have something like update image s.images. Oh, like basically update image is just going to take in s.clicked image, right? All right, gamers. Let's see if we can update our image. No. No. I am starving, brother. It's a man. The tall, skinny figures thrown the oats at me. Me, brother. Because clicked image is not -1, man. Okay. Okay. Thank you. Okay, cool. I think we should probably say something like, we definitely have to say except click image equals to -1 here. If we clicked again. All right, cool. Yeah, we definitely have to check that s.clicked. Yeah, basically, yeah. First of all, let's not do something like update image with uin30. So if index is smaller than 0, we immediately return. And then also update image should only be if not s.dragging, right? Okay, so this is the scroller. We can rotate her. Okay, so I think now the last thing we will implement for a valid image viewer is like the close to last thing is the gallery. So the gallery view. So let's go and actually say we want to render. So this entire atrocity, we will put this in one function. Oh my god, I love it so much. How I can just do some random shit like this. Render main page is just that. And then void render gallery. And then we can just say if s.in gallery render gallery, else render main page. So bool in gallery. By the way, before that, I definitely forgot something, which is rn color border is equal to rn no color. And then if I is equal to s dot image index, then we say border is equal to rn black. And then else if hovered or on image, yeah. Then we say border is equal to from hex. Where do we have that? This thing. So like that. and then we say border, and then we say yeah, border width. Let's have border width. Well, yeah, we can also just say something like border dot r not equal 0. Then we have a border, meaning we want a width of 3, and else we don't want. And then here we can say border dot r equal 0. So when we have a border of alpha 0, only then we want this, and else we want 0. Okay, so let's check that quickly because this is kind of important. Okay, cool. Yeah, nice. Okay, and also before we okay, what we definitely have to fix is that the where is it? It's probably in here. Wait, let me quickly do this. Thank you. So here, image.jpg. We definitely want s.image.filepath. And here, so this is that, yeah, and here we want dimensions buff is something like 512, and then char, and then s.printf dimensions buff %i x %i, and this is just s.image.width s.image. Yeah, so the file path is ignoring those two, meaning this definitely has to be fixed. So space right size right of file path plus equals space right. Yeah, now they are always correctly there, even if the file path. Okay, perfect. Okay, so now let's have toggle or like something like gallery handler, gallery handler, and it just says in gallery is equal to not in gallery. So let's have the gallery handler here, and this is probably, I don't think that this is like such a good icon. So let's go to cheat sheets, gallery. Bruh. I think it's a good icon. Yeah, I think it's okay. Okay, so yeah, that's the gallery handler, and then render gallery, the final boss. Okay, let's have the tile size to be like 250, right? Because the gallery is going to be consisting of equally spaced and sized tiles. So let's have usable width also. And then like the usable width is going to be render.render width minus padding times 2. All right, makes sense. And yeah, then basically what we're trying to figure out is the width of rows, because we want to center, and for that we have to know what width we are going to be having. So for that we can just divide the usable width by the size, right? So the tile size. So let's say un32t tiles per row is equal to un32t, and then this is going to be usable width plus padding divided by size plus padding, so tile size. And if the tiles per row are and it could theoretically happen that tiles per row is 0. So let's say if tiles per row is equal to 0, tiles per row is equal to 1. and then the row width is just per row, and then the row width is just, and then the row width is just tiles per row times tile size plus tiles per row, and then -1 plus padding because times padding, because the last one is not having any padding in centering. So this is basically the row width, and then we can also calculate already the start x, which is going to be s.render width minus row width divided by 2. And then we can basically render. So our I is equal to 0, I is less than s.n gallery images, I++, and then rn texture image is equal to basically literally that. Literally. Okay. So this, and then we have scale is equal to float tile size divided by float's rendered image dot height. And then we have, yeah, this is very, very gallery size.y is tile size.y. Or just like tile size, right? Also, we're going to need an x, which is going to be start at start x, and a y, which is going to be starting at padding. And okay, then we can actually render the image. We can say image pos is equal to vec2 x and y, and we want to image render ex. Let's just copy the image render ex. Border and all of this is actually just going to be nothing. So let's say rn no color 0, and then let's maybe say 15, but I don't know if it's going to be looking good. Yeah, and then the thing is that we have to, what we're trying to do is centering the image inside the tiles. So let's set up a cull start x s.render x plus tile size, and this is the end x, by the way. So let's have the end x. Start x is going to be x. And then we're not rendering at image pos, but we're rendering at plus tile size minus image size dot x divided by 2. And then we're going to render at that and at image pos dot y. All right. And this is basically centering and not overflowing due to the culling, right? And then we unset index and unset start x. s.render. Yeah, and then we're just going to say x plus equal tile size plus padding. And then we can just easily say if basically I plus 1 percent tiles per row, which is going to give us the index inside of the current row. If that is equal 0, then like the next index, then we want to say x is equal to start x and y plus equals size plus padding, right? Okay. Would you look at that? It's a gallery. All right, that's actually very cool. Now the thing is that we actually want to be culling So let's set an end y of s.render height minus padding. And then we want to rm unset cull and y. Yeah. Okay. But now we want to check basically if we are on the image, right? So we can actually borrow that again. So let's check that. Mouse is just going to be vec2s. Mouse is equal to vec2s mx my. And we are basically checking are we on the image. And then we can do stuff like, yeah, we basically want, what we want is because we are doing this kind of cull shenanigans and stuff like that, after that, we want to check if we're on the image, and then we want to render a rect that is on top and just has a border, right? So the position is actually kind of a tricky one because when the image size is .x is greater than less than the tile size, then we want to center, right? Makes sense. Because we don't want to left align. So then we want to say basically the centered position, so this, and then else we just say image pos. And here we were going to say the size is going to be when we are overflowing, so image size.x is greater than tile size. Then we want to say we want the tile size, and else, like, then we want the tile size, and else we want the image size to be fitting but not going beyond the tile. And this is just going to be image size.y. And 0 and rn no color for the actual color. And then we are going to have, if we are on the image, we want our beloved this color. So if we are on image, we want this, and then else we just want no color, and 3 for the border width. So now we actually see what image we are currently on. Nice. Okay. Okay, but to actually go to the image that we selected, let us do bool mouse down is, yeah. Let us basically copy mouse down, and also, yeah, okay. Mouse down, let's just copy that, render gallery, and then we check mouse released. Released is equal to not mouse down and s.mouse pressed. If mouse down and then not s.mouse pressed, then we say s.mouse pressed equal to true. And then we can basically say, here we can say if on image and mouse released, we want to say s.mouse pressed equal to false. s.in gallery is equal to false. And also update image I. Right? So let's see. Can we update our image? Yes, but it's scuffed it out. Okay. All right, so we're actually not going to take image size because image size is actually the overflowing size. we want vec2s tile size for x, and for y we want the actual size, so basically image size.y. I think this fixes the issue of, yeah. Okay, and we can select. Nice. Okay, but we cannot scroll. So yeah, let's implement scrolling, right? So let's have a float gallery scroll, and let's have scroll callback. Why is a scroll callback? We basically check if s.inGallery s.gallery scroll is plus equal basically the tile size, so 250 plus the padding, so 10, and then times data y. And then we say s.gallery scroll is equal to min s.gallery scroll and 0 to not like scroll up, right? And we just return. And then let's go to render gallery, right? Okay, and where's startx? Startx, man, here. Before that, let's put the total height, and for that, let's figure out how many rows we have by just basically dividing up. So we have s.nGallery images plus tiles per row minus 1 divided by tiles per row, which is just division, but biased to add one more than it would be when you round up. So basically rounded up division instead of rounded down. And that's how many rows we have. And then the total height is going to be rows times tile size, right? And then plus rows minus 1 times padding. This is going to be the total height. And then we are just going to say float max scroll is equal to negative total height, but plus s.render height minus padding times 2, right? Yeah, and then we can check s.gallery scroll is equal to max s.gallery scroll and max scroll. All right, and x is start x plus s.gallery scroll. What the fuck? This is the most cursed thing ever. This was like retalk, the most cursed thing ever. I never want to see that in my life again. Okay, we can normally scroll. And we have those nice anime girls and we can look at them. But one problem is, you see that I clicked on this, but this scroll bar didn't change. You know what I mean? We definitely have to implement scroll to selected, right? So scrolling to a selected one is actually, it involves figuring out where is the position of the selected one, and then basically centering basically centering it. So basically adding the position plus the centering formula with the gallery, and that's basically it. So this is the offset, because when you know where it is, you can just say s.scroll offset is equal to the position of it, and it would be left, but we want to have it center. So we say plus basically centered. So let's implement void scroll to selected. And where is gallery size defined? Here, right? So gallery size is this. Float padding is equal to 10. And then let's have something like target x is equal to 0. And then we basically mimic the rendering of the scroller. So where does the scroller do its rendering? Basically here, right? So let's get that. Okay, and instead of max scroll, we just do target x, and then plus equal image size plus padding, and yeah, right. And then we say float. Basically, we want to have the scale of the currently selected image, right, inside the gallery, and then selected width would be s.image.width times scale, right? And then s.scroll offset is equal to negative target x plus gallery size dot x minus selected width divided by 2 to center it, as I said. And then we also have to update last offset, obviously, because yeah, then if we didn't do that, then next time we would scroll, it would start all over from 0 again. So that's scroll offset. And then what we basically want to have is scroll to selected. Okay, so let's say we chose her. It did not scroll, right? Okay. So scroll to selected, man. What are you doing? Why? Ah, bruh, because we're scrolling to the end. But we want to scroll until s.imageindex. Okay, okay. Okay, so we selected her. We're still scrolling to the end, man. Still scrolling to the end. Okay, but scroll, yeah, look, scroll to selected has to happen here. And also, we want to post an empty event again. Okay, so we selected her, and it correctly selects her, but it selects her in a weird position. Like, why is it not centered as I wanted it? Let me check. Plus the gallery size.x, which is correctly that, minus selected width, which is correctly that. Okay, so what the fuck, man? Okay, let's try. Okay, we selected this. Okay. Yeah, it's not really centered, right? Oh my god, think I might have found the issue, but I'm not sure. Yeah, I think this was the issue, right? Because padding was 10, but we are using a padding of 15, okay? So now it's correctly working. Nice. Okay, one quick thing is in the resize callback, you should probably scroll to selected as well. Scroll to selected. Let's just fucking statically define that. So static void scroll to selected. Okay, let's say we are here. Yeah, it's correctly rescaling that choice. Right. Okay. Also, basically the last feature we're going to implement let's have a void charcoal back with a GFW window you and send in code point, and then if code point equal a, we are going to say if we're basically going to say update image, and then if s dot image index -1 is less than 0, we return, and then s dot image index is equal to s dot images. Basically s dot image index minus minus, and then we update image with s dot image index, and we say else if, and then also we want to scroll to selected, right? And else if code point equal d, then we want to do the same thing, but +1 is greater than or equal to s dot nGallery image -1 plus plus, and then GFW, where's your GFW? Set charcoal back s dot window with the char callback, and then we want to make nice. Oh no, why did the tag fault, man? Image index is a u and 32t. That's also very bad. In 32t, and yeah, one thing that is actually very important, dir path is equal to argv int argc and argv, or something like that. Char pointer argv int argc. What? Int argc char pointer argv. Is it like this? Okay. So argv at 1, and if argc is less than 2, then fprintf, let's see, error, fv specify a directory to open, and then we return 1, and we say cannot use directory via path. Okay, specify directory to open, Let's put that right up here. Let's say we want to open C. Nice. All right, that's actually super nice. That's actually a very good file view. I would use that. You can expand it however you want. And it's just 800 lines of code because we are not bloating any shit. And the Runara library is also literally only 2000 lines of code. So if you're using GTK or any, or like, God forbid, Electron, I would, yeah, kind of restructure my thinking a bit. Maybe think about different uses of different things. All right, I think that's it for today. Full screen is also very great. All right, guys. So I'll see you in the next one.